Section 9.4 is about direct, joint, and inverse variation. Now, variations are relationships between values, and those relationships are created based on something called a k, which is called a constant of variation. You're going to see the k is going to show up in each one of our variations that we're going to use here. When you see the words varies directly, you want to create an equation that looks like this: y equals kx. That's called a direct variation, with the k being the constant. So let's see how we can use that. Come down here, we see the words y varies directly as x. When you see that, you know you're going to have y equaling the constant times x. Now we have some other information. We're told that when y is a 12, that x is negative 3. And then we're asked to find y when x is 16. So if you look what we have two equations, one of which we can use to find the k. Then we can take that k, plug it into the second one, where we can find the unknown value that we're looking for. So here, to find the k, I'm going to divide both sides by negative 3, and I end up with k equals negative 4. So now I'm going to go over here and use my negative 4 constant of variation, multiplying that by 16, to get a y value of negative 64. Here we see a variation called a joint variation. The word joint here means together. So when you see the phrase y varies jointly as two other values, then you're going to write an equation that looks like this. Y equals, there's my k again, but this time I have x and z because they're working together. So I go down here and I see y varies jointly as x and z, so I know it's going to look like y equals k x z. Now I'm asked to find y, so I don't know what y is, when my x is an 8, so I'm going to put 8 in for x, and when my z is a 3. So this is what I'm looking to find, and I know that my y is a 16 when my x is a 5, I'm just reading from here, and my z is a 2. So in this one I can use this equation to find the k, and then plug it into this first one to find the y that I'm looking for. So here, to isolate the k, I'm going to divide by 10. And so I'm going to get k equals 8/5. That's my constant of variation. Now I'm going to plug 8/5 in over here to find the y that we're looking for. So 8 times 8 times 3 is 192/5. I could reduce that and make it 38 2/5. That would be a fine answer. Or I could even plug it into a calculator and get 38.4. Either way, that's what my y equals for this joint variation. The last kind of variation we're going to look at is inverse variation. So when you see y varies inversely as x, you want to create this kind of equation. I actually like the second one better, because when I think of inverse, I think of fractions. So y equals k over x makes a lot of sense to me. So here it says r varies inversely as t. Notice we don't have y and x anymore. But that's okay. You're still going to write it as r varies the k over the t. So that's my inverse variation in this one. And it says r is 18 when t is negative 3. And I want to use that to find r when t is negative 11. So first we've got to find that constant of variation by multiplying by negative 3. So k equals negative 54. So I go over here and I use negative 54 as my constant and plug that in. So r is either going to be 54/11, or you can write that as 4 10/11, or you could even write that as 4.90 repeating.